Hello, everyone. My name is Paschalis Arampatzis, and I work as a specialized account executive for the Eastern European team at Siemens. I would like to thank Advanced Engineering for being a trustful partner for so many years for Altair. And I would really like to see them thrive in the Siemens partner ecosystem. Today, I would like to give you a bit of market insights we see with our customers, but also give you a glimpse of what comes next. We are lucky enough to meet with customers across the world. And I don't know what is the sentiment here, but everyone asks for the same thing. They want China speed to be competitive. But what we have seen is that even in China, the domestic competition adopts advanced simulation and AI technologies in order to maintain their competitive edge. Moving beyond traditional simulation solutions, we see that our customers face enormous challenges. We understand that they face advanced time-to-market needs, escalating product complexity, and productivity constraints. It's no longer enough to bridge the contact between the physical and the digital world. We have to eliminate. We understand that we have to innovate faster. We at Siemens, we understand this challenge. We understand that engineering is powerful, but is currently fragmented between different versions, different systems, different teams. But before we get into the glimpse into the future, let's acknowledge where we are. Currently, we are already saving billions of dollars for our customers by reducing the numbers of prototypes with best-in-class simulation. But we understand that currently, simulation is slow. For example, pre-processing alone can take up to 10 hours for 300 parts. Solving time can be from 45 minutes to 20 hours. Add to that 4 hours for post-processing. And if you want to do a design space exploration, optimization analysis, that can take up to weeks. Complexity is real, but wait doesn't have to be. If we can accelerate and automate each stage, we can actually compress the time from weeks into hours, without, of course, compromising the engineering fidelity, because we understand that all decisions are based on it. That's why Altair and Siemens teamed up together to bring into life the most complete AI-powered engineering portfolio. We enable our customers explore innumerable what-if scenarios, design and produce complex products first time right, save a lot of materials and costs by reducing the number of physical prototypes, and of course, continue their optimization journey without having to worry about the results. But how we can save time for our customers? We understand that validation is usually the most slowest part in the design process. It's usually the gap between the CAD and the FE models. With SimSolid, we managed to eliminate that bottleneck. No simplification, no messing, just results 30 times faster. But we didn't want to stop that. Our next step is Physics AI. With Physics AI, we want to bring validation in real time. We want engineers to explore and validate designs instantly. For example, in automotive world, we want to cut what it used to take decisions from weeks to make it real time during the design phase. And we understand that engineering has never been limited by physics. It has been limited by the limitless possibilities that we have in our hands. Different geometries, different configurations. And our strategy at Siemens is to use AI to explore and narrow the selection set. We do not want to change the physics engine. What we want to change is what we aim and how we can make it scalable. Let's take, for example, Leonardo. Leonardo had an issue with radar transmission loss caused by in-flight vibration in the helicopter's radome. What they did is that they used SimCenter Freckle to solve this problem. They actually used a multi-physics approach in order to create a digital twin by combining the antenna's structural and electromagnetics models. Our approach is to support you at every stage of your AI journey, starting from co-pilots up to scaling to physics-based AI agents across different simulation workflows, from insight to validation. As you can see, on the left side, there are different simulation workflows that are currently automated. Finite element analysis, CFD, and even systems models. What if AI could connect all this as a thread? What if it can be a layer that it can move across this digital thread and take information from different solutions and enable connected decisions for the teams without actually someone manually having to grabbing all this information together? What if we can have a multi-layer orchestration layer that could transform your simulation models into actual connected knowledge that can support your decisions at every stage of your product development? We understand that engineering intelligence can help you to test, improve, and optimize designs across different physics with less manual work. Your designs, your intelligence, powered by agent development and orchestration. Our commitment for engineers, our commitment in innovation is to provide faster engines and, of course, to make engineers work faster with this embedded engineering intelligence. We don't want just to add AI in your workflow. We want you to build your workflows inside an AI native ecosystem. Thank you a lot for your attention.